Okay, so this is lecture number 14, 14 or 13. Um, Today there is no lecture in the sense, this week there is no lectures in the sense that we will not have any new material learned. And what we'll do is today we are going to have a midterms review where you can ask any questions related to last year midterm questions or your homework. I uploaded solutions, so those solutions you can have it while we are having midterm, so you can see the solutions. Um, Tomorrow also we'll have a office hour. I will have extended office hour tomorrow because of the midterms. So it'll be 1 to 2. Usually I have office hour. So let me check. Um, yeah, so 1 to 2 I have office hour usually. Either I can have it from 12 to 2 or I can have 1 to 3 p.m. Either is fine. So let me see how many of you can make it tomorrow, either of these options. So what I'll do is I'll create a poll for tomorrow office hour, um, 2 hour window. So midterm office hour on Wednesday. So that's 5:12. So one option, usually we have 1 to 2. So what I'll do is either 12 to 2 p.m. or 1 to 3 p.m. Now all of you have classes, so that's why I wanted to make sure um, you can make it, whichever one you can make more. Okay, so I launched the poll, so you can see which one, let's see, more students are available. I mean, you would be available 1 to 2 anyway. That's supposed to be original. Just I want to stay either earlier or later. I mean, I can stay longer. It's not a problem for me at all if you guys need. And there is no class tomorrow. Um, Class is, during the class time, I release the midterm, so you can take either that time or you can take any time. And again, you can open the question. It's really not, it's not a duration specific. Okay, that means you, as soon as released, you can open the question and you can, whenever you want to do it, you do it. Um, but you have to upload your solutions um, by midnight on Friday. Okay, and these questions are not meant for 12 hours. Okay, so just because I release 24 hours window doesn't mean that you'll spend 24 hours. Okay, it should be 2 to 3 hours. And these are the similar question I put in the in-class exams for 2 hours. So just one extra question, small questions. So typically students take these exams 2 hours window in class. Okay, so I don't change it. This is also open book, so you can't have a lot of other um, advantage. Um, yes, you'll upload on Gradescope. The midterms will be released on Gradescope, so you'll take it from there. Okay, so I end the poll now. As you see, many of you are available from 1 to 3 as opposed to 12 to 2. So tomorrow office hour, I will change my calendar from 1 p.m. to 3 p.m. So one thing I will tell you that until I release the solutions, you can ask, not solution, question, you can ask anything about midterms. So I'll release mostly within the class time. So before that, if you ask any question, I will answer everything, whether it's in the midterms or not, because you have not seen the questions. Okay. But once you see, and once I release the midterms, any question you ask, you have to ask openly through the campusware. The reason is I want also the same answers to be available for everybody. Okay. So it's kind of way to help rest of the class if you ask any question. And so if you are taking midterms tomorrow, not tomorrow, sorry, on Friday, if you have doubts, first check campusware, just in case there are other similar question people asked, so that you don't really get confused with a similar thing. Okay, all right. So that's as you see, the some of the solutions there is a reason why I didn't release the homework one, because we finished grading almost. We'll release the solution right on your grade scope. It's homework one was mostly word questions, like what's the different types. There is no right answer. I mean, there are right answer, but not like what I wrote in the solution is not the only answers. There are many options. So that's the one thing. And homework three, I released. I mean, I have it right now. I'm just checking one examples. Just to give you one heads up that homework three last questions is Excel file. So even you don't see the solution in the notebook, I have Excel file that I upload. So you can change numbers so that you can play around with that. I'll help you for your any question you want to answer in future. Okay, so that's all for the announcement. Now, I guess, what we could do is we could solve some questions. Usually what I do is I create a breakout room, but I think, what it does it if I create a breakout room right now, I cannot record it. I want this to be available for rest of the class. So I'll create a breakout room, means I will leave from the room from you so that you have open discussions without me, and then I'll join back. Okay, so that way the entire class is a breakout room. I'll be the absence. I'll get into one of the breakout room where I'll stay there for 5 minutes, 10 minutes to give you open um, forum for conversation without me. Okay. So don't join any breakout room. I'll just join and come back. Okay, so I'll just hide inside while you guys are discussion. Okay, so first thing is, I midterms 2020 solution is here. You can check later, but I think first thing to do is let's try one of the question on your own. Okay, without even seeing the solution. That's why I didn't release the solution for last midterms, because I want you guys to try here so that you see how you can approach these questions. Same these two. So let's try question 2, where it's kind of mass balance. So one of the question is fine, whichever one you want to try. Homework 3 question is very similar to the last question of last homework. Not last homework, or before that. So that's already, we have the solution, so it's not going to change much. You just given the same thing. Okay, so I will not solve question number 3 in this class today. So let's try this one. I want you guys to open this PDF or the documents or whichever one I uploaded it. Open these documents and read these questions, question number 2, and you guys start discussion. And it will take a while for you to read it. So what I'll do is maybe what I can do is I can one of you can become a host, and then I'll leave the room. Oh no, that's fine. Let me see how I can do it. Create a room. How do I do this one? Breakout room. Okay, I'll create one breakout room. And so I create a breakout room. So that one, no. Let me see. I'm not doing it right. Instructor. Okay, so I create a breakout room which is called instructor. So that means I can get in there and I'll announce before I come back to your room. Okay, so that way you guys can discuss. I just don't know whether how your discussion can be recorded. Well, I don't want to record your discussion. Let's put this way. That way you can discuss whatever you want to do freely and ask questions. So I'll pause recording when I'll go to the breakout room. Then I'll start recording when I come back. Okay, so this is the question. Question number 2. You guys read it and see where you have difficulties and discuss that. And I'll back in 15 minutes. Okay, then we'll solve it. And then I'll give you some examples, more questions, discussions. Okay, so you have it. Yeah.
Professor, you also posted a sample midterm like last week or 2 weeks ago, but they're all the same version, right?
Yeah, yeah. This is the same question.
Okay. Okay, for sure. Thank you.
Yeah. Okay, so try this question because there will be one mass balance question, which will be you got to have that understanding of how to set it up. You are not going to, you know, solve differential equations other than what is already there, you know. And so I'm not expecting you to solve differential equation in the midterms, but the form, if the same, the solution will be very similar form. So you just have to write the same solutions. For instance, retention pond. If you have input, output, you have a steady state solution. You don't have to solve it. If you know the form, how the final answer, you can just substitute that and say that this is what you assume. Okay, so this is a good questions where you have a lot of different things, so it will take a while. So let's take 15 minutes for you guys to try and understand it, 15 to 20 minutes, and then I'll be back. And I'll be here as long as you guys need. It's not 6 o'clock. If you need more time, we can answer any questions. Okay, so I am going to join. I'll pause the recording. All right, so um, I gave you one question to work on before the break. So I want to just reiterate that um, the office hour tomorrow is 1 to 3 p.m. No class on Thursday. Also, I wanted to mention that the methodology that is due supposed to be this week. You don't have to worry about it. Send submit on Tuesday. Okay, because you have midterm, so I don't really expect that you guys to work on the project. So that's why I say project method or anything that you wanted to discuss on that should be, you don't have to submit this week. Submit next Tuesday. Um, okay, so that's all. So you have two questions actually. So as you see in the last year midterms, you have they have given choices for the question number 2. um, they could um, they could choose to answer any one of the questions, either these questions or these questions. That's why it's written to question number 2A or question number 2B. So some students solve these questions, some other students solve the other questions. So that may be similar format. That way give option for you to try whichever question you feel comfortable. At least one of the mass balance question would be like this. Okay. Um, okay, so is this the one you solved or try to solve during discussion? Okay. So
Wait, Professor.
yeah.
So for our midterm, at least will it'll be a similar format where we choose like Q2A and Q2B, and they're both like different types of mass balance like questions.
Yeah. Yeah.
Okay, thanks.
Okay, so I think the any question before we discuss, because we have the solution here is you can always refer the solution to see how it works, but to understand it takes time. So first thing is to any mass balance equations or mass balance problem where you have to recognize input, output, and where the reaction happens or where the things um, change because of a reaction or any kind of process. So before we get into this much, let's see. You see that. Let me see. My mouse is not working, so let me check. Maybe. Okay, so now it should be right. Okay, so any mass balance equation, you have a reactor. The very first thing you have to do is any mass balance equation, whether it's a detention pond or any system that you are checking, check what is inflow and what is outflow. So there will be inflows, something has to be in and something has to be out of the system. These two things you have to check all the time. Okay, sometimes you may not have anything out, or sometimes you don't have any flow in or out. So that could be also true, but at least you have to recognize those two. So there is something mass coming in and mass leaving the system, and that mass could be water or it could be pollutants. Okay, so when I say mass, it's because it could be water and pollutants, one or both. Okay, and because it's storm water, obviously there will be some water. Okay, and contaminant is not added directly unless there is like somebody spill it. And so you got to check those two first. So what is in, what is out. And then also you got to see whether your system has any volume or reaction term. So that's K. Okay, K is reactions. So contaminant concentration can change because of reactions. So that usually for most of the system is a first order reactions, but it will tell based on the K value, you'll be able to predict that value. If the K equal to 1 over time, that is first order reactions. Okay, in this system there is no reaction in the dissolved pollutant. There is a, the reaction is basically settling. Settling is the reason why things are changing here. So you have TSS or suspended solid coming in, suspended solid leaving the system, but inside the tank you have suspended solid removed by settling. Okay, so this reaction here, the reaction here is settling. Everything else is exactly same. Okay, so the net the most important mass balance, the generic mass balance equation is is this, um, total mass of pollutants or water change in the system is equal to all the mass coming into the system, whatever coming in, it could be because of flow, it could be somebody adding, minus whatever the mass leaving the system, plus mass reactions. So reaction could be plus or minus or right here. If the reaction decrease the concentration or mass in the system, then you will say that it's minus. Okay, if it is adding to the system, that's going to be plus. Okay, so now this dm by dt is basically change of mass per time. For steady state, for steady state, dm by dt in system equal to 0. That means there is no change in mass in the system. Whatever is being added is whatever the things being removed by reactions or just by flowing out. Okay, and so that's the generic form. And then obviously dm by dt is also, you know that if it is constant flow, then it's basically a concentration term times flow term. Okay, so this is concentrations, this is flow. And if the system, so that's basically in or out. Okay, so if it is in, then that's how you write. Okay, so I'll write in or out. You'll have same thing in or out. But the system itself usually is a detention pond or a reactor. Okay, so that doesn't have any flow. There are things moving in, but usually that's defined by a boundary. So when for the system, dm by dt is usually defined by a boundary which has a volume. Okay, so that's volume times dc by dt. Okay, so these are the couple of things you just have to know that if there's any case, you know. And then for the reaction, that's only one thing that we didn't write is um, I'm going to write it here, dm by dt reactions. Again, reaction happen inside a boundary because that's the reactor has a shape or the size. So usually that reactor volume is system V volume. Okay, volume time dc by dt. And as I said, for mass balance equations for the reaction, dc by dt for first order reaction is, I'm just going to write react, is minus kc. The reason negative is a reaction is decreasing the concentration. If it's creating, it's a first order. So if you submit all those, if you put everything here, no matter what kind of equation, you will create a equations that has concentration term, flow term, and a reaction term. Okay, and then basically you have to solve it, and that's exactly every, no matter what problems we have, you can solve any problem like this. Okay, so that's just the generic way of solving any mass balance problem. You just have to identify what's the flow in, what's the flow out, and just set that equations there. You know, that's, as I said, you put the value, everything. For instance, if I, you know, one of the homework question was about detention pond. So let's say this is the detention pond, and things are coming in, things are going out. So let's say Q is coming in, and let's say the concentration is C in, and concentration is C out, and same flow because there is no changes in, you know, so there is no other way other unless the volume is changing. So the volume is V and reaction is K. Okay, so that's the generic way of any detention pond or reactor. So let's say this is reactor. So reactor could be a pond or any things in the natural systems, lake, and this could be a river or stream. Okay, so all those things could be. You could have multiple. Okay, so you could have another line if you want to write. Um, you could add as many as possible. And so if you write the reactions or the mass balance reaction, so basically you are saying system boundary is basically the lake. Lake is your boundary. Okay, so that's your, this is your system. Or you can say this is my control volume, this is the system. So that means if you write this way, as I said in the very first one, dm by dt system in, dm by dt out, reactions. If you write this one, so let's say the very first one, system is a shape, right? So it has a system boundary. So it's volume times dc by dt of system. Now what is coming in is basically there is no reactor coming in. You are basically putting things by flow. So that's why this term is q times c in. So this is dm by dt is to take the form of flow and time concentrations. Same thing for this, q c out. This is out. And then reactions, you know that for a reaction to happen inside, that's basically dm by dt is the same thing for my system. So dc by dt reactions. And you know that for a first order reactions, that means you can say that dc by dt is minus kc. So that means if you write these equations, you just remove this one, dc by dt is case c inside the reactor. Okay, and if it is completely mixed, you are saying that there is no reaction outside. What is inside the system has to go to the outside. So if complete c equal to c out for completely mixed. For steady state, this one would be 0 if it is steady state. If it is settling tank, the only thing that will change is this term because this is the reaction term. So if in that equations, the only thing that reaction is happening is settling. So that the only thing you'll put it here is settling rate of removal of particles by settling. Okay, so that will be dm by dt directly. So that's basically any question, any mass balance question you can solve like that. So now you have it here. If you write the mass balance equation, so basically it says, it says stormwater retention tank is designed to remove suspended solid, allowed for some disinfection of stormwater flow. The tank has a constant volume, so basically volume is given. Maybe considered to be well mixed. That when it says well mixed, it's saying is what is inside the reactor, the concentration will be same as what is leaving the system. So concentration term in the out effluents as well as inside the reactor is same. Flow enters to the tank with the two separate pipes, one carrying a steady flow of certain flow rate, another steady flow of certain flow rate. So there are Q1, Q2. So there is two inlet here. So there are two incoming. The suspended solid concentration in both flow is certain amount. So your reaction or the concentration is given for both same. A flow Q out leaves the tank through a single outlet. So there is one outlet, two inlet. Okay. So that means, what it's saying here is if I'm writing the very first equations, how this is coming here. Let's see, what's the reason I don't. The mouse doesn't work. Let me see. Let me see the mouse. The pencil has, oh, I see. The pencil has a low charge. So what I'm going to do is see if I can use my hand. Okay, so if you see mass balance equation, no, I cannot use hand. So I have to wait. I'll have to explain by talking about it. So if you see the first term, that's why I'm going to use the, just to enlarge it and I'll explain how it is. This is mass balance. So all it's saying in the left side is let's see. What is this term? This is the system. The settling velocity of the solid particle in both inflows is Ws. So that's basically saying how quickly particles are settled. That's the reactions. Okay, that's how things are moving from the system. What must be the tank area A to achieve a removal of 80% of suspended solid entering tank? So it's saying that what's the size of area should be so that 80% of the solid has to be removed. So as you see over here, it just says that um, if you don't see any of this thing over here, that you have the out is Q out and it has a concentration term and that concentration would be 80% will be removed. So only 20% will be gone here. Okay. And then you have input Q1, Q1, that's basically concentration time flow rate is in what is coming in. What is removed? is what's reaction. So what you can say is it's a steady state. So that means you can assume that there is no change in net um, change in system concentrations over time. So it's always going to be consistent everywhere. So that means it's going to be zero. Okay. So basically, you're talking about the concentration in water. Okay, even though they are settled, that's removed from the system.
Wait,
So that,
Professor,
yeah.
sorry, do you mind re-explaining the steady state assumption again?
So
Because it,
yeah, steady state means at any point, if you pick some water at any place in the system, the concentration will always going to be same. Okay, so if you take, let's say, water from this tank today versus tomorrow, that concentration always going to be same. And even though you are adding all the time, you are adding suspended element, why the concentration is not increasing is because whatever you are adding is 80% are removed and 20% remain in the system and leave the system. So all the time you're maintaining the same thing. So that means anything removed is being added to the system. So that's steady state. If the volume doesn't change with time in the system, or if the concentration in the system doesn't change with time, that's steady state. Okay, so that means dm by dt, yeah, it says that it's a steady state. How do you know whether it's steady state? Um, let's see, it's written here. Carrying a steady state of this is basically in time. It didn't ask you what's the concentration at certain time. The moment it asks you, what is the concentration after 5 days? That means you already know that it's not steady state. Why it is 5 days? Because it's a time the concentration is changing every day. So anytime if I don't ask you any question, what's the concentration after a certain time, you can assume that means it's a steady state just by referral of that. So that means your the concentration term here will be dm by dt will be zero, and dm by dt of in will be q in times concentrations in. So q in times css in. So that's the plus q in 2, which is the second inlet, times the concentration. That's the dm by dt in. Okay, what is coming into the system? Concentration times flow rate. What's leaving the system is q out times css out, or the suspended concentration out. So that's basically your what's leaving the system. Now what's the reaction is dm by dt is where you have to write a different equations. That's the only terms that you didn't, uh, at least we didn't write it here. So, but for that one is written the what's the particle remove is given here, the suspended sediment velocity. So that means saying that your particles are moving at certain rate. And I told you already here in the hints, mass settle is concentrations times the settling velocity times area. Okay, so that's the dm by dt reactions, because mass settle is what's the mass reacted, because it's not reaction per se, it means it's being removed by a reaction that's called settling. And that equation is given here. See, concentrations times settling velocity times area. And why it is that the dm by dt? If you think of dm by dt is basically volume times concentrations, right? And so if you see concentration here is css, and the volume is basically area times height. Okay, so that height terms is the velocity. Um, that height over time is velocity. Let me see my um, pencil is charged. Okay, the pencil is charged enough so that I can write it here now. Okay, so let's write it here so that before even we see that solutions, let's write it here. So you have a settling tag, things coming in, leaving the system. So that's in, q in 1, q2. Okay, so that's basically the, yeah, q in 2, and then q out. And then this is basically c suspended solvent in. Okay, let's say css out, and then you have a settling velocity at ws. is the settling velocity. That's the reaction. So basically this is given to you. So, and this is steady state. So that means if you write this one, dm by dt of system equal to 0 because it says steady state. And if that's the case, then you can write the second form. So this 0, which is the dm by dt, the very first term will be everything that's coming in. So that's q in 1 times css in plus q in 2 times css in. Basically, that's take care of. So this one, I'm just going to write everything step by step so that you guys know. So this is dm by dt in. Okay, every mass that coming into the system is this. What's leaving the system by flow is q out times css out. And then what's reaction? What is being reacted is basically what's here. The reaction is basically settling. Okay, how much mass is being settled. Now, for reaction, usually what you write, volume times, this is normal you write, right? Volume time concentration. So, well, or another way to write is, because this is not like a constant concentrations or all that, I'm going to write more generically. So I'm going to say, what is the total mass? Mass of particles settled is basically concentrations times concentration of suspended solid settle times the volume of the water within which it settled. Okay, so if you write this one, now concentration, this is basically whatever the things is in the system, whatever the, I'm just going to write it here, concentrations. And volume of the tank is basically area of tanks times the height of the tank. Okay, so that's where the thing settles. So if you see if you pick anything, particle is settling in that depth. Okay, this is the area and this is the depth of the tank. Okay, the height of the tank, or let's write height. So that means you could write this one as area of tank and height of the tank. So area of tank, this is height. So this become, because it's steady state, that means you know that the concentration of particulates in the reactor is also constant most of the time. Okay, so that means you can take C out, and area of the tank is not going to change. And this is basically height is how the particles move, that the location of the position of the pipe, the particle is going to change. So dH over dt, and that dH over dt is basically the velocity of that particle as it settles. So that's Ws. Okay. So now if you put all these value in this original equations of dm by dt system equal to dm by dt in minus dm by dt out dm by dt reactions, or I'm going to write here settling. And you know that for settling you are changing the concentration, you are decreasing the concentrations. So that's why this. So if you put all this value over here, the set reaction or settling, you will be, if you substitute all this value, you should get this number. Okay. Now, there is one thing that we have to do for the mass balance, that you know that the volume of water is not changing. So that means mass balance for water is everything that water is coming in, Q in 1 plus Q in out, or Q in 2, everything that flow coming in has to be that the flow leaving the system. It's just the water. As of steady states, that has to be Q out. So that means you can write here, this one would be Q in 1 plus Q in 2 times CSS out. And this one, in the system, this C is CSS out, because completely mixed. That means you are saying that the concentration inside the settling tank is same as concentration outside the settling tank when they leave the system. So if you put all these value like assumption over here, you will get these answers. Okay. So everything else is basically that. Fraction removed is whatever coming in, or removed divided by what's coming into the system. Total amount of mass coming into the system. So this is all, this is basically dm by dt in. Okay.
Professor,
Yeah.
could you explain why we're able to make the assumption that CSS out is the same as the concentration that's settled?
Not concentration that settle, that concentration that remain in the water after settling. So it's in a complete, so wherever it says here, let's see. For any, for instance here, when I explain this particular one, the concentration in here, concentration C equal to C out. You can assume this one, or what you are saying here is that whatever the concentration of contaminants in the system, or in this case settling tank, is same as the water that leave the settling tank. And that's usually case if it's completely mixed. And let's see if it is said somewhere. Or another way to it says that, okay, so it says it's a well mixed system. So it means that, thus it means that, your concentration in the effluent is same as concentration in the reactor. Basically, whatever you are taking out from the reactor is what is inside the reactor. And it's only happen in the well mixed systems. So I guess, once you set up like this way, you can answer any questions. And if you see what is fraction removed, is basically fraction settled by what is coming in. Okay, that's percentage remove is basically whatever coming in, or what is removed divided by what is coming in. So that's all in terms of, then it's just basically rearranging the equations. So the way this equation is written here is that I skip many steps. Okay, so this is, or I didn't skip, this is a solution from another, the previous instructor for another class. But if you break down how I read here, you should get the same answers. Okay. Rearranging the equation and solve for the unknown. That's all he did, or she did. So I guess, what I'm going to do is, because you have the solutions, you should do by yourself and see if you can't understand certain step, you can ask on the campus where. What we can do next is maybe, try these questions. That way, this is a similar practice. It's exactly what we solved. Now that you understand how to set up the equations, you can try this and see whether you can do the same thing or not. But the difference here is, let's see. Um, yeah, it's the same type of reaction. So it's really not much different. So it's again, it's not that different. If once you have the solution, you can understand it.
Professor,
Yeah.
could you explain the solid water partition coefficient in part C from the last question?
Okay. So that's basically the KD of the, if you see in the bioretention systems, if you have let's say, I'm just explaining solid partition coefficient. Okay, so in the retardation factor, you have is rho bulk density times KD divided by porosity. And so this retardation factor means velocity of water divided by velocity of contaminants. Okay, that's how it slow down. And the reason why contaminants slow down any places is because of the contaminant adsorbed to the soil. Okay, and that absorption is KD. So this is absorption. And that's what we call solid partition coefficient in that places. In this particular question, you don't have soil like normally how it is in the, because it's not moving through soil. What is happening here is that in the system you have lots of particulates, suspended solid. So that means all the pollutants can stick to those particulates. So they can absorb on that particulate. So that's what it means. It means that KD is basically adsorption of the contaminants on the particulates, like how it was in the soil. So originally the KD equation is concentrations in soil divided by concentration in water for linear equation. That's how normally people write. So what that means is, if you know the concentrations after absorption in water, concentration of contaminant in water, if you multiply this KD, you should be able to say what is the concentration of pollutant in those suspended particles. So that means this is soil or particles. In this case, it's particles. And again, this is contaminant. It's not concentration of contaminant. It's not concentration of particles. The medium is particles or water. So this is contaminants. So if you know the concentration of contaminants in the particles, if you know how much particles are removed, that much contaminants are also removed from the system. So that's all it means. So another way to say is, so the unit of this one, concentration of contaminant in water, is basically mass of contaminants, volume of water. Okay, this one is mass of contaminant divided by mass of solid. Okay, so that means if you know what's the concentration of contaminant in the particles, and if you know how much particles are removed, if you multiply that, you know how much contaminants are also removed. So that's all in that system, because in compared to the previous questions, the difference in this question, here in these questions, you have just suspended particles are removed from the system. But in other questions, what it says that, no, actually it has some more to, I have to check. But in other system, not only the particles are removed, this particle also absorbs some pollutant, dissolve pollutants, and also removed from the system by settling. So that's how the answers are all written. So what I will do is, you all try at least here to understand the solutions. If you still don't understand, I'll break down like how I did here, and provide another solutions which has every steps written. Okay, but I want you guys to try first, okay, because it's already written here. So that's for the, so we have two choices now. Either you guys can try here, any questions, we can discuss that, Or another thing we could do is I can quickly go through, no, not necessarily go through. What we can do is we can quickly go through the solution from all homework. That way, you at least I can tell you what questions are short questions, what are long questions. That way, then you can continue discussion on this.
Professor.
Yeah.
Also, I wanted to ask, are there any Excel related questions? Because I feel like we sometimes in the homework there's like Excel related stuff, but there wasn't a lot of guidance in class to help us figure out how to solve those problems and how to look at data.
So if you have a equation, you can plot that equation in Excel. So that is not really Excel problem. That's more of a you. Another thing to say is, let's say, how about we see the question on this homework um, in the last year questions. That we can see because there was Excel question there. Basically, what it means that let me see over here. Let's see. Let's say this one. Okay. You solve for these equations, and then what you got here is your solution become, because steady state is 0, so it's basically the solution is for retention pond is Q C in minus Q C out, which is basically C, it's the same thing, plus B, or not plus, it's minus. Okay. So that means your variable here is basically the flow rate. So there are a couple of things. Your Q is given, C in is given, phi you can calculate, K is given, volume is given. So volume you're not going to change it, K it's not going to change it, or C in may change, may not change. Let's say flow doesn't change, it's given. So that means you have your two variable is this C in and C out. C out. So what you can do is, if I say that plot C in as a function of certain thing, how the C out is going to change if you change the flow rate certain way. So all you have to do is you create a column and see. So you'll, instead of having one number, you write many numbers. Let's say flow rate changing from 1 to all the way to 100. And I ask you what is the C value, and then you plot it. So what it means that visually you show that as you change the flow rate, the concentration is going to change this way. So basically, I will ask you to graph something which is already, you know the equations and the values. So it's not like you will solve something using Excel, just
Okay.
making a graph.
I just meant that in one of the homework questions in like the very last homework, I
Oh,
think
I see.
homework 3, like last question.
Okay,
It's
so
like some
you're right. So for the unit, you mean the unit hydrograph?
yeah, there's a lot of like stuff with like rainfall that I thought were just like very quickly like glanced over that.
Okay, so that's a fair question. So that's why I say that solution, I give you an Excel file, right? So homework last question solutions, I give you a Excel file. So if I ask a question, that's the Excel file. So what you can do is you can check the Excel file and see if you don't understand it. You can ask either on campusware or come to the office hour.
Okay.
And I must say that I didn't set the question yet, so I don't know what question I set. So that means you can ask anything. There may or may not be any question on Excel. And if there is a question on Excel, it has to be exactly homework. So you're not changing something very different.
Wait, sorry, I'm still a bit confused. So are you going to post some Excel file right now or?
Yeah, the solutions are Excel file. The solution of that question that you said about homework is Excel file. So you'll have that
Okay.
access to that.
And also earlier in the course, you published 2 Excel files with a ton of data. I'm not like, what is that exactly?
I see. Okay, well that's the one you let me see.
I'm just confused because there's so many different Excel things going on. I don't know what they actually mean.
Okay, I see. Well, let me check. How about we check the CCLE directly? That way it's easier. Okay, so I'm going to start a new cell. Okay, let's see. Homework 1. So there is no Excel. This is no Excel. Week 4. Okay, here. So there are some Excel file here. That is what actually the unit hydrograph. So this is something you guys need some point to use the question. So there are no, these are the things, same thing I will use. So it's not different. Let me see. So for you, you should not worry about these two Excel files. Just look at the homework 4 solutions. That's the only thing
Okay.
you would need. That makes it a lot
Okay.
easier for you to get confused otherwise.
Thank you.
And also look at all your quiz questions, because these are the same questions. Similar question will be asked on midterms as a short questions. And in quiz question, you may not have any calculation, but in midterms, in the short question, you will do calculate. And you will explain the answers. That way I know why you chose certain answers. So it will not be multiple choice, but at least you'll have the answers that way. So what I would suggest is let's look at each homework and see which are the long questions that you should prepare for those long questions. So let's see, this is a question, homework number 4, not here. Okay, so this is homework number 4. All these questions except question 5. Question 5 is one of the long questions. Okay, so you should absolutely know how to solve these questions. This is one of the long questions you will be asked. Okay, because you are designing a bioretention system. That's very important stormwater infrastructures in many places. So this question 5 of homework 4, you should know how to do it. These questions are short questions. These are not long questions. And mostly you will be given like, um, you will not be asked something like calculate answers, but mostly it could be because of a conceptual question. This is also a short question. Question 1, 2, 3, 4. These are all short questions because all you are doing is plugging the value and getting answers. As long as you know which equation to use, you'll get the answers right away. So these are not long questions. But as I said, in this particular one, some of the, okay, this is the one, question B. Estimate the time required to empty the tank halfway. That was integrations. I will not ask this question as a short question. If I ask, that will be a long question because you have to go through the process. But in these midterms, I will not have any extra integrations that you didn't do in the class. Okay, so whatever you have done is already part of that. You are not asked any other new form of integrations or setting. I mean, the typical things that you already see, that part of the class. Okay, so let's see homework number 3. Homework 3, let's look at this one. This is the one I think, Ambrose, you are asking, is hydrograph. That's the only one you have Excel file. Yes. I'll give you the solution as Excel file so that you see how things are. Okay.
Okay.
And I never asked this question as Excel in my last 3-4 years. So I don't think I'll ask this question as I'm just know how to do it. The reason is this is a very project oriented question. You will do that as part of the project, not as part of the midterm. So I will not, I can say for sure, I will never ask this question as a midterms question.
Okay.
But you should know this one at least for your project.
Okay.
And this one, any question where you have to look for numbers in your handouts, I will not ask as a long questions, because that's basically looking for the right numbers and plugging a value. It's tedious, it takes time, it doesn't really test anything you're thinking. So I would normally, this kind of question I ask as a um, or the concept used in this question will be as a short question. Question 4. This is also a short question. This is like concept question. You will not be asked as a calculating any, because this is very chemistry oriented. I will not ask normally question like chemistry as a long questions. This will be more like a concept. Same thing, oxidations. You'll have a short question on balancing equations or oxidation reactions, or just finding what's the oxidation state, like how you had in your um, quiz. Settling is a long question. Like you see, we have solved 2 questions on settling on last midterm. So this was a long question. Okay. So settling tank is design is a long question, or at least a mix of all other question. So in that context, in homework number 3, only settling tank is a long question. Everything else would be part of a short questions. And question 4, the homework 4, as I said, bioretention system is a long question. And let's go back to the previous one. Uh, homework 2. Homework 2 is a mass balance. Okay, so that means as you see, settling is just one of the reaction. So mass balance, this is just mixed with settling or without settling. So this is a very important homework. At least one of the mass balance concept will be there as a long question. So I would definitely solve this question for sure, all of those questions. Look at the solutions. It's already on the on CCLE, and check if you don't understand some of them. And again, I don't look for the right answer at the end. As long as you have the right process, you will get the full credit. But I would suggest that because 24 hours, I do expect you to write the final answers. Okay. And with the units. And also make it distinct so that people, the TA can find it. T and I can find it easily. So I would say that question, homework number 2 is very important homework. And homework 1, as you see, homework 1 is very, I would say the answers are very much, write 3 reasons for why water scarcity will increase in urban areas. These are the questions I will ask as a short questions where you'll test your concept. There will be nothing memorization. So I'm not expecting, for instance, here, what is the section of 303D of clean water? This is basically you are looking for information. Now that's something I will not test your memory. Anything I ask is more concept. So this kind of question will never be in the midterms. Even though it's open book, I will not test for those things. All right, so I think what we should do now is, as I said, this is all basically short concept questions. So summarizing quickly, mass balance is one question, settling tank is another potential questions, and third is retention pond, not retention pond, bioretention system. So those 3 are the potential long questions, and everything else are short question based on the concept, nothing about memorizations or finding numbers in your handout. All right, so having said that, let's go back to the, I see some chat window. When is the quiz answer going to be available? Oh, so it's not available. So let me see. Quiz 3. Where is quiz 3? Quiz 3 is here. Let me see. don't know, it should be available by, I mean, I usually by default, it should be available at the end. Let's see, timing, review options. Oh, I see. Okay, so sorry, I didn't even realize this. Okay, so quiz 3 answers are, you should be able to see it. So if you see the, let's see, what's the grade? No. The average is 9.13 out of 10. So this is the distributions. As you see, like pretty much most of you did well. Yeah, I don't. So the question number 1, 2, 3, 4, 5, 6, 7. Question 7, 66% got it right. That's a little bit difficult one. Everything else, I don't want you guys to see the screen of any student, so that's why I'm going to go back. Okay, so that's okay. We have some time now. I think what we should do now is you guys work on the second questions, and I'm here and on the breakout room. So anybody who want to just not discuss that question and come to the breakout room to ask me any question is well also feel free. But you spend at least next 10 minutes, 10-15 minutes on that questions, and then I'll come back, join the main group, and we'll continue to discuss as long as you need for that questions. Rest of you can leave if you want to, because tomorrow we'll meet again for the the office hour. Okay, so let me create a breakout room. Again, what I do is I'm going to join the instructor breakout room. So I'll be there for next 15 minutes. You guys discuss that question, the one question we didn't do it. Okay. All right. Good luck with that. I'll join back in 15 minutes.